Hello and welcome to another Asian Agribase podcast. I'm Hatu, Asian Agribase regional correspondent from Vietnam. Today is our Q-turn. Our regional correspondent from the Philippines is talking with Dr. Mel Umandal about infectious bursal disease or IBD in poultry and developments about the disease. Dr. Umandal is currently the veterinary service manager for layers of Seva Asia. He's a veterinary medicine graduate of the University of the Philippines, from where he also received his master degree in veterinary epidemiology. He has over 20 years of experience in the poultry industry.
Hi, Dr. Umandal. Thank you for taking time to talk with me today.
The pleasure is mine, Isa.
No, infectious bursal disease or IBD, which is also known as Gumboro disease, is one of the major diseases in poultry, not just in Asia but around the world. Despite the presence of vaccines, it's responsible for huge economic losses for poultry farmers. So let me get down to it. How big a problem in Southeast Asia's poultry industry is IBD today? And where does it stand among the key poultry diseases present in the region?
Thank you for this question, Isa. IBD or infectious bursal disease is regarded as an economically important disease in poultry, not only in Southeast Asia but all over the world. Since the first recognition of this virus in 1957, the disease has spread to major poultry producing areas in the world, and by 1965 was recognized as a major pathogen affecting poultry. In Asia, one of the earliest article I found was this publication from Avian Pathology Journal, indicating IBD as one of the most important poultry disease, along with infectious bronchitis, Newcastle disease, Marex, leukosis, foulpox, coryza, fowl cholera, and even aspergillosis. With the exception of leukosis and aspergillosis, I think most of them are still big concerns up to now. And it would be nice to point out as well that several genetic companies also conducted surveys among their customers in Asia Pacific, and always IBD ranks prominently among the top diseases affecting poultry in their respective countries. For example, in the Philippines, there was a survey conducted in 2018 by Seva Animal Health and the Philippine College of Poultry Practitioners, and IBD ranked third after avian influenza and Newcastle disease.
In terms of value, how much is the regional industry losing to IBD annually?
Well, in reality, it is difficult to put value on the losses attributable to IBD as no data is available.
Mm.
But let me tell you this. The truth is, when we talk of losses, most of the time, we are only referring to the direct visible losses involved, such as mortalities, in which we account for all the inputs like cheap cost, the amount of feeds consumed, or the vaccines, which were already given. For some, they do also compute for invisible losses such as condemnations in the dressing plant or loss of fertility in breeders, delayed sales of animals and finished product, and so on. It should be noted that when the flock has IBD, additional cost on antibiotics and other supplementations has to be factored in as well. And most importantly, lost time, in which the number of cycles per year can be affected due to delays in loading.
Can you please differentiate between IBDV and the VVIBDV? Are both present in Southeast Asia?
Yes, you might be referring, Isa, to the classic IBDVs versus the VVIBDVs.
Mm-hmm.
Well, what we termed as classic IBDVs were the first isolates showing classic manifestations of gumboro, such as reduction of feed and water consumption, mucoid diarrhea, huddling, and the reluctance to move. Through the process of evolution and being a virus, which by the way is a double-stranded RNA, that's why they call it bi-RNA or Birna virus. They are prone to genetic mutations, recombinations, and reassortments. Hence, by the 1980s to 1990s, the poultry industry saw the emergence of these very virulent IBDs, which on top of the clinical manifestations seen on classic infections, are more pathogenic, causing more morbidities and mortalities. So basically, the major difference between the two, as the name implies, is related to pathogenicity, which eventually leads to mortalities and losses. With the advent of molecular epidemiology, my colleagues both from the SEVA Animal Health Scientific Support and Investigation Unit in Pilaxia, Hungary, and our regional office in Kuala Lumpur was able to map the occurrence of VVIBD in Asia. And I would like to quote from this document. From a data set spanning from a period of 13 years, that is from 2007 to 2019, with more than 1,125 laboratory results coming from 10 countries in Asia using PCR and genetic sequencing, IBD represents 32% of all the detections, in which 73.5% is VVIBD. Earliest detection is at day 12 of age, while 62% of all detections were concentrated between day 28 and day 35. In 2019, most of the samples for IBDV detection were sent to one of our accredited laboratory in Malaysia that uses the same method of detection as our lab in Pilaxia, Hungary. During this year, 2,731 Bursa imprints were sent to this laboratory from 9 different countries. And again, I would like to quote from this document, field IBDV strains were detected in 225 flocks, from which 75.6% were very virulent IBD virus, and 24.4% were variant IBD virus. Now, it doesn't mean that IBD is the most prevalent disease in Asia, as this represents only a snapshot of the total investigations done all over Asia. But I think this is the most comprehensive laboratory data that we can assemble.
So VVIBD is more prevalent.
That is correct, Lisa.
Okay. So I've read that the disease can manifest either in subclinical and clinical forms. Can you discuss in more detail these two types, these two forms?
Yep. There are actually 3 main forms of Gumboro disease.
Okay.
Please note, Isa, that I am interchanging Gumboro disease and IBD. And the one you failed to mention is the immunosuppressive form. So yes, manifestations can either be immunosuppressive, clinical, and subclinical, and that they are differentiated depending upon the type or strain of the IBD virus and its pathogenic consequences. Take note that it is possible to have strains from the same genetic family, and yet pathogenicity and immunogenicity can still be different. The key symptom observed in chickens with the clinical form is the reduction of feed and water consumption, which is also common in other diseases. Other related symptoms that can be observed include mucoid or viscous whitish diarrhea, huddling, hunch position, or sleeping with their beaks touching the ground. After an incubation of 3 to 4 days in clinical infections, the symptoms will start, and mortality can go as high as 5 to 20%. Upon necropsy, it is common to observe for bursal and muscle hemorrhages. After the peak of the symptoms and mortality, which usually is around a week, the flock will recover. However, broiler weight gain can be delayed by 3 to 5 days. Subclinical form, on the other hand, impacts not just the field performance, but also key performance indicators in the processing of broilers, which is in the slaughterhouse. There can be an increase of condemnations such as skin scratchings, muscle hemorrhages, and increased rejections of livers reported in some publications. It can be explained by the fact that Gumboro subclinical infection creates the possibility of secondary opportunistic infections such as colibacillosis. One of my good friend, Dr. Marcelo Paniago, even mentioned that if the harvested flock has poor weight uniformity, that's what happens in some clinical infections as well, it impacts the performance of the slaughterhouses too, as the line speed is reduced, having an adverse effect on the cost per carcass. Similarly, lower weight gain also harms the slaughterhouse's performance, as it spoils the forecast for the carcass weight. The immunosuppressive form, meanwhile, predisposes the flock to other infections, as the bursa involved in the production of B lymphocytes are compromised. The presence of the subclinical form of the disease is obviously more difficult to monitor than when the clinical form is present. A protection failure in the face of a subclinical Gumboro outbreak can easily pass unnoticed, which is not true if the disease is clinical.
Um, you mentioned earlier that this is a virus that has the tendency to evolve and mutate because of the type of virus it is. So,
Mhm.
what's new with the virus now? How much has it evolved? And is it easier or more difficult to address and control now?
Uh-huh. So nothing much has really changed about the virus per se, except that in recent years, we have seen changes both in its antigenicity and pathogenicity. I mean, the ability of the virus to induce lesions or disease. Focusing on its impact in the field, there are evidences that seems to indicate increase in its capacity to inflict both direct and indirect losses. The gene responsible for this is what we call the VP2 hypervariable region of the virus. And again, being an RNA virus, as previously mentioned, is prone to mutations and reassortments. These mutations and reassortments, by the way, are responses of the virus to its host and the environment. So regarding your question on control, well, we need a strategy. It needs understanding of the concept of stopping the Gumboro cycle. Briefly, when the virus are able to enter the farm premises and eventually infect the birds, this is the time when disease happen, right? Prevention entails all efforts to stop the virus from entering the farm's premises.
Mhm.
But how do we deal with a resistant virus such as IBDV? Definitely, biosecurity will be very relevant. The objective of prevention, therefore, is to reduce the probability that the flock will be challenged. On the other hand, controlling a disease includes both prevention and protection. Prevention, so to speak, is the first line of defense. And if it fails, we have to make sure that the susceptible population is protected against the negative impact of the disease through vaccination. As we know, we cannot stop the birds from being infected, but we can reduce probability and the economic losses by stopping the Gumboro cycle through good biosecurity and proper vaccination. As one of the speakers said in one seminar I attended, she said, in the control of diseases, you have two options. One is to keep it out, and the other one is to live with it. But we don't really have to live with it, di ba? If we have other options.
Besides vaccination, how can producers protect their flocks? You mentioned biosecurity.
Mhm.
And so if the disease occur, what steps can be taken to control its spread and to ensure not all the birds are lost?
Just to reiterate, Isa,
Mhm.
protection involves a strategy of preventing the flock from being in contact with the IBD virus and making sure that the immune system of the flock is capable of mounting an immune response in the event that the virus was able to enter the birds. In short, biosecurity and vaccination goes hand in hand and cannot be standalone. Specifically, it should be emphasized that we have to start with good quality chicks under high plane of nutrition, and the environment during the whole growing period should be conducive enough for them to be able to express their true genetic potential. may they be broilers type or layer type. In the fortunate event that there is an IBD break, the main objective is to prevent it from spreading to other flocks. Restrictions on movement should be implemented, and supplementation with multivitamins might be helpful. Antibiotics can be given to prevent secondary bacterial infection, so this is not the treatment regimen.
Are there new technologies now available against this disease? Can you please discuss
Uh,
them?
Currently, there are several technologies available in the control of Gumboro. You know, Isa, I'm coming from a vaccine company, so this is
Yeah.
really my line of expertise. So let's discuss the different technologies available right now. First is the conventional live vaccines, but let's skip it as they are not considered new technologies anymore. So let's start with the vector IBD vaccines. Vector vaccines consists of the vector, which is normally a large virus which one can make insertions without compromising its ability to replicate and induce immunity. And the actual gene insert, which is a protein from another virus primarily responsible for protection. For IBD, the usual vector used is Marek's HVT strain, and the insert is the VP2 gene of the IBD virus. Protection is mainly humoral, which is produced progressively as HVT spreads cell to cell and takes time. Immunity generated is due to the VP2 insert, and as they are not whole viruses, does not have the capacity to colonize the bursa, which is important in stimulating the whole arm of the immune system. It is worth mentioning that not all vector vaccines are the same. They may differ on the insertion site, the promoter, the vector, and the strain used as insert, and this will impact on speed and magnitude of replication, which has an impact on protection. The next technology is immune complex vaccines. As the name implies, immune complex vaccines consist of the whole IBDV virus and the antibodies attached to it. They are also called antigen antibody complexes. And what makes this technology unique is that once the immune complex vaccine is injected, they are not neutralized by the maternal antibody of the chick. Instead, it will be captured by the follicular dendritic cells of the spleen, and through time, once the maternal antibody gets low, the whole IBD virus antigen will be released, travel to the bursa without the interference coming from the maternal antibodies, induce bursal colonization, which effectively triggers the production of complete immunity. Thus, it can be called a self-adjusting vaccine. This action prevents pathogenic viruses such as VV-IBDs from co-infecting the bursa. Again, not all immune complex vaccines are the same. They differ primarily on their ability to break through maternal antibody titers, which is a function of the innate immunity of the chick. Thus, an ideal immune complex vaccine is one which is given correctly in the hatchery, as unvaccinated birds will remain unprotected and by practical reasons should be able to break through maternal antibodies earlier as growing period becomes shorter and shorter.
Which
Yes.
is the more commonly used now?
Definitely the immune complex vaccines. There are billions and billions of birds which were already vaccinated by the immune complexes vaccines. So that's it.
In what direction is the research in IBD heading now? Is eradication a possibility at all?
So, in my opinion, the challenge today in IBD research is to quickly identify emerging IBDV disease variants. Quick and accurate diagnosis is imperative so as to know which type of IBDV and its type of pathogenicity we are facing. In this aspect, surveillance and monitoring will definitely be a key. There are new vaccine strategies that is worth looking into. With the increasing virulence and the rise of novel variants, the vaccine should be able to address the realities in the field which includes not only protecting the birds against the negative impact of the disease, but also the ability to significantly reduce the amount of viral shedding in order to protect future flocks in the absence of a comprehensive and well-executed biosecurity program. Bioinformatics, biostatistics, data science, and real-world evidence will be tools in IBD research. Realistically, with the way the poultry industry is organized right now, it is my opinion that eradication per se will be very challenging.
Okay.
The battle between the virus and human intervention has been going on since time immemorial. And just when human intervention is about to happen, then the virus will find a way to evolve and escape, and the cycle goes on.
Dr. Umandal, thank you so much for taking time to discuss this with us. I've
Yeah.
learned a lot from you about IBD, and I'm sure many of
Uh,
our listeners will also learn quite a bit.
well, the pleasure is always mine, Isa. Thank you as well for having me in your podcast, and thank you very much as well.
The IBD virus will continue to threaten the global poultry industry. But as you've just heard, armed with the right vaccination technologies and proper biosecurity and management, flocks need not to be in danger. We hope you enjoyed today's podcast. Visit www.asian-agribees.com for a wealth of information about Asia's animal protein industry and to listen to our other podcasts.